here we go. Alright, so that was the wrong version. Alright, this is what we had. Okay. So just a normal Flappy Bird clone. You get points as you go through the things and you can die. And it restarts, and that is about it. And today, all I'm going to be doing is a few viewers have requested to see certain things implemented. So that's all I'm going to be doing. The first one is someone wanted to see how to do game saving and loading. So it's one of these comments. Implement a save system. So I've already put like a bit of code down here pretty much that shows how it works, but let's do that. So just a quick overview of how the entire game is structured. Everything's just in this game window at the moment. We've got font for drawing text, images for the player and the obstacles in the background and foreground. And then we have something called the game state, and the game state is everything in the all the data that represents the current state of the game, and this is what gets updated every single frame and gets drawn every single frame. So everything is inside this one instance variable here called @state, which makes it quite easy to save and load games, because that's all the information that you need to save and load. There's nothing else. Like these images and the font, they're pretty much constants. You load them up once when the game starts and they never change, so there's no point saving and loading those. It's just the things that can change you want to save, which is what the @state here represents. So I'm just going to put in two methods, save and load. We need to save it to a file somewhere, so let's say that the file is called save path, and that will be, what did I say here? Home plus FruityBat save. So this is like a Linux sort of standard. It's where if you're gonna save something, you put it in the home directory, which is just here on the Mac. So I'm in a user called screencasting, and this is just screencasting's home folder here with applications, config, desktop, all that. And there will be hidden files in here that because it starts with a .FruityBat save, that just makes it a hidden file. And if I were to look in there at what I already have, you'll see there's a bunch of .dot files already. So related to Bash and some Ruby stuff, Vim. That's just where it goes on OS X. As for Windows, you probably don't want to put it there. You want to put it somewhere slightly different. And this dot out the front is not going to make the file hidden. You have to do some other thing on Windows to make the file actually hidden. But we're just going to use this because I'm on OS X, and that's what you do on OS X. What I might do is just make sure that this is correct. So I'll just print that out, make sure it looks right. Uses screencasting.FruityBat save, that looks correct. Okay, so we've got the path. The next thing, well, we're going to be saving a file to that path. So file dot binwrite probably. Let's have a look at the documentation for binwrite. Name string offset. So So the name is the save path. So that's the file we're writing to. The second thing is what we're going to write. So something is going to go in there, and the opposite of save is load. So we want file.binRead, which I believe is a method. Yes. And well, I should have looked at that a bit better. Name length offset. Okay, so there's only one required thing, save path. So I'm using file.binWrite and binRead, which they basically take a string. For the write, it takes a string and it writes the entire string to whatever file you say, and it does it in a binary sort of way. The normal file.write method, that one, it also writes strings to a file, but it takes into account text encoding. So if you have funny characters in UTF-8, sometimes things might go wrong. And we're not actually going to be writing tests, we're going to be writing a blob of binary. So it makes sense to use the binary write, and it's not going to be encoded as text at all. There may be text inside the binary somehow, but that's not, we're not concerned about that. So, like I said before, the @state holds everything that we want to write to the save file, but we can't just write it straight like this because it's not a string. binWrite expects a string, so somehow we have to get state to be a string so we can write it, and that process is called serialization, where you take a data structure and you turn it into just a blob of binary, is serialization, and then on the other end, when you take a blob of binary and you convert it back to a data structure, that is deserialization. And we're going to use one built into Ruby called Marshall. So the marshalling library converts collections of Ruby objects into a byte stream, allowing them to be stored outside the currently active script. This data may subsequently be read and the original objects reconstituted. So pretty much just what I described, serialization and deserialization. And it's got a code example here, marshall.dump, which is what we will want to use. Marshall.dump and marshall.load, I'm pretty sure are the ones we want. Takes an object, and the other arguments are optional. So I'm pretty sure we can just go marshall.dump state, and that should be it. Marshall.dump state turns state into a string. We write it out to file. The opposite is marshall.load. Source may be either an instance of IO or an object that responds to toStir, which means a string will be fine. So file.binRead will work. So marshall.load. So read in the whole file, put it through marshall.load, and the result should be the state that we just saved out before. So that's basically it. One goes from the state data structure into a binary string, which gets written to a file, and then the reverse direction is read a binary string out of the file, convert it back into the data structure, and then we'll just put it into state here. And as we saw with the game restarting, you can just clobber this state instance variable with a new one, and everything just runs fine. That's because I set it up to do that on purpose. So where does the game restart? Restart game. So here you can see clobbering the state with a new one restarts the game. So that should be a totally safe thing to do. So we can also do it for loading games. Now we just need to do it. So we need to call these save and loads from somewhere and make sure that it works. So I'm going to do it on a button down Fruity Bat, like Flappy Bird, isn't a game that you really want to save or load. It's sort of, you play the game and then you die and then you stop playing. It's not play the game a bit, save it, and come back after dinner to finish it off. It's not one of those types of games, but just to demonstrate how it would work for that type of game, I'm just going to use some keyboard shortcuts to save and load. So letter S sounds good for save, and KBL, whoops. We have a somewhat of an issue. Load is actually a keyword used in Ruby. Well, maybe not a keyword, it's a method. So we don't want to use the same name as the Ruby keyword. I'm going to change this to save game and load game. And change it up here. Okay, that's better. So letter S saves, letter L loads. Let's give that a go. It may crash. So flap a bit. I'm hitting S to save now, after 4. And so I quit it, run it again, hit L for load, and we're back to exactly where we were before. So just to demonstrate that one more time. Oh, I'm terrible at this game. Let me get through at least 2. After the second one, I'll save. Okay, saving here. Then I died, but I can just load it back and die again. There we go. So I'm just loading it before I died and cheating so I can win. So that's saving and loading. Pretty simple stuff. It all just works off Marshall. So if you want to learn more about marshalling in Ruby, I'm not sure where to look. The documentation's a little bit dense for it. Maybe this one, object serialization. This is comparing it to Java. But yeah, generally it will take anything you give to it, serialize it. This isn't always true. Sometimes your custom classes and things won't serialize quite right. For instance, I was trying to serialize a gosu color, like gosu color red. If you would try to Marshall dump that, it's not going to work, because gosu color red, the color class, actually comes from a C++ library. So gosu is a C++ library that has a binding in Ruby. And when you try to serialize those objects that aren't real Ruby objects, they won't work. So you might need to do a little bit of converting around those to get them to serialize, but generally you throw anything at it. So we've got vectors here. Let's have a look at the vector class. This is something that we made last time. This is serializing fine and coming back out again fine as well. We have rectangles. So another thing that we defined there, and they're made up of vectors. That's all fine. It knows how to serialize those automatically. So that is saving and loading. The trick you have to remember to get this to work properly is all of your state, everything that could possibly change in the game, is held in one place. In our case, it's the @state instance variable, and it should be just pure data. So we don't have any, so game state here, it's just a hash basically. It's a bunch of data. It doesn't have very much behavior associated with it. So rectangles have a little bit. We've given them a few methods, but they aren't anything that would break if you replace the entire rectangle. So sometimes you're doing things like observation, where you say, tell me when this object changes its position, and then you run some other code. that will all break if you try to replace the object with a new one, because it's not observing the new one, it's observing the old one, so it's not going to run anymore. But I've specifically avoided using observation just for this purpose. It makes things a lot simpler, and I don't think you really want to be using observation. In general, try to avoid it, because it adds a lot of complexity to your code, and it's usually not necessary, especially with games like this, where you just have an update step. You have state, update step changes the state, which we can see here. So gravity and scrolling and spawning new obstacles and stuff like that. And then you have a draw, which takes the state and draws it on the screen. Pretty simple stuff. No need for observation if you structure it like this. So I will move on from saving and loading now. Corey also asked about breaking things out into separate classes as well, which I will get to shortly. But before that, I want to do this one up here. How would you implement player animation? So if you look in the directory that is on the images directory, it's on GitHub, there's actually 3 images here, Fruity 1, Fruity 2, Fruity 3. So that's the bat has a flying animation, but if you run the game, it's like paralyzed. Looks like it's made of concrete. It spins at the end, but it's not animating. And I actually forgot to implement that last time, so that would be a good thing to implement now. First step is we probably want to load in those images. So this is called player. I'm just going to load these in as, whoops, player 1, player 2, and player 3. Okay, so we've loaded in the 3 separate images. We just broke things because I changed it from player to player 1, so we've got to find where that is first. I believe we're looking for :player. There. Alright. Hopefully that still works. Yes. Okay, so they're all loaded. The images are loaded. The next step is, as part of the state of the game, we have to know which frame of the animation are we currently on, and we also have to know how long have we been on that frame. So if we're going to play the animation at 5 frames per second, that's 200 milliseconds per frame. So every time 200 milliseconds elapse, we have to go to the next frame. So we have to record that somewhere, which one are we on and how long until the next frame. I'm going to do that here as, got a bunch of player stuff already. Player frame, start at 0, the first frame, and player frame, let's call it remaining. So this is how much time left for the current frame before it flips to the next one. And we'll want to set that as a constant somewhere. We'll do player animation frames per second. Define that up here. Frames per second, 5 frames per second sounds good to me for the moment. Frames per second. Okay, so we set the constant in frames per second, but this value here, player frame remaining is not in frames per second. It's actually in seconds. So how many seconds are left until we have to flip the frame? And the answer to that you can get from frames per second. You just have to invert it. So 1 divided by frames per second will give you seconds per frame. So it's just flipping the value there. And I would expect that to not crash or anything. All good. Yep. Okay, so we've got the state that handles it, but we're not actually using the state at all yet. We also don't have a list of the frames. So player 1, player 2, player 3 exist, but they're in amongst background, foreground, obstacle. What we really want is just an array saying these are the player frames. I'm just going to chuck that here for the moment. So the player frames are player 1, player 2, player 3. And that's what it's going to cycle through in the animation. Now we want to use the player frames. So images player 1. What I'm going to do is make a new method called player frame, which returns the correct image for the current frame. And what that is we look in player frames for the current frame. I believe that's what we called it. Yes, player underscore frame. So we get the current frame out of this player frames constant, which gives us a symbol, and then we look up that symbol in images. So player frame is like 0. The 0th element of the player frames constant is this symbol here, colon player 1, and then we look that up in images. Now we just have to use that everywhere instead of where we're just going straight to the images. So player frame. Again, player frame. Player frame. And that's it. So we're not using player 1 anymore in the code. And there. So it's not crashing, but it's also not doing anything because the frame never changes. It's set to 0 at the start and it never updates. So that's the next step. We've got to make the frames change, and that is part of the update step. Okay, so I'm going to put it here before this return. So this return sort of pauses the game before the game has started. So here you can see the game hasn't started, but it's still scrolling. So we'll make the bat flap as well while the game hasn't started, which means it has to go above the return. So this is the basic setup for frame by frame animation. You have a list of frames and you have a frames per second value somewhere, and every frame you count down the number of seconds that have elapsed. So player frame remaining decreases by the delta time, which we've set up here. So that's how many seconds have elapsed for this one frame that we're updating for. So that goes down. The next step is you see if it's gone below 0 or if it's hit 0. So if the frame remaining is 0 or lower, then we know we're on to the next frame now. So in this case, the player frame goes to the next frame. So we add 1 and goes to the next frame. And then the new frame has a new remaining on it. So the player frame remaining also goes up by however many seconds per frame. In our case, it's 1 on player animation frames per second. So this is the general thing. The timer goes down till it hits 0. Once it hits 0, you go to the next frame and you put the timer back up to how much it was supposed to be for this frame. This isn't exactly right at the moment, but that's the general gist. The places where it's not exactly right is this is going to go up, so it's going to start at frame 0, then frame 1, then frame 2. We only have 3, so that's the end, and then it's going to go to frame 4, which doesn't exist, 5, 6, 7, 8, forever. It's not going to loop. So to do looping, what you want to do is you still add 1 to the player frame, plus 1. The frame equals the frame plus 1, but you have to do it modulo the number of frames. So player frames.size, that's how many frames in the animation. So what this is going to do, if you've seen FizzBuzz, which I'm sure you have, and if you haven't, I wrote an article about it not that long ago that you can go have a look at. Modulo, it's like the remainder after division. So we're going to do modulo 3 because there's three frames. So when you get to frame 4, 4 modulo 3 is 1, because 4 divided by 3 is 1, and the remainder of that is 1 as well. So 5 modulo 3 is 2, because 5 divided by 3 goes once, and the remainder is 2. So this makes the frame loop. As soon as you get over the maximum number of frames, it loops back to 0 again. The second problem with this is this code will run totally fine, and you won't notice any problems probably, but let's say that you have a lag spike and it's 100 milliseconds per frame, and you have a lag spike, and one frame runs for 300 milliseconds. So that would mean that you've gone 3 frames in a single update. And in this case, this will not handle it. It will only do a single frame because it's an if. If it's below 0, it's going to go to the next frame, and that's it. Next time it comes through the update loop, it will notice that the frame remaining is still negative, and it will update the frame and update the frame for the next couple of times. But that's not exactly what you want. You want it to update 3 times in a single update step. So if 300 milliseconds have elapsed and it's 100 milliseconds per frame, then you should be going 3 frames into the future. And the way you do that is easy. You change this into a while loop. So while the player frame remaining is below 0 or equal to 0, you keep going to the next frame over and over again. In practice, we shouldn't ever see a lag spike big enough to trigger that happening, but I mean, if it does, at least the animation is still running at the correct speed. So theoretically, that should be all we need to update the animation. Or not. I have an infinite loop. So what am I doing? This is looping forever. While the frame remaining is smaller than or equal to 0, go up a frame and then add. I'm just going to print this out here. That doesn't seem right to me. So it's constantly negative. Which isn't right. And why is that? It should be increasing. animation frames per second. Oh, okay. So I said frames per second was 5. Seconds per frame is the inverse of that, 1 on 5, which is wrong. 1 divided by 5 is not 0, it's 0.2. And the reason why it is doing that is because we were using integers and not floats. So 1 on 5 will round down to the nearest integer, whereas if you do 1.0 on 5.0, it will give you the correct result. So what was happening was this 1 on FPS that we were increasing was always 0, so it was never increasing. It was going down, but it was never going back up again, and that's pretty easy to fix. We just do 1 on play animation. I have to do that here as well. And just for good measure, let's also change that to a float. Okay, so now it should be working. And there we have frame by frame animation. One more thing I'm going to change about this is, well, actually it looks pretty good. I quite like that sequence. So the wings are down, then they're in the middle, then they're up, and then they immediately go back to down again. It looks like flapping. When I originally envisioned this, I didn't expect it to look good like that. So we got frame 1, frame 2, frame 3, then it jumps back to frame 1 again. What I thought was going to happen is frame 1, frame 2, frame 3, back to the middle. So it's going to look more like this. Up and down. I'll show you how to implement that, just because that's what I was expecting, even though that looks pretty good, that flapping there. This is really easy to do. We just got to find the frames again. So 1, 2, 3. And we just put the middle frame back in, player 2. So it goes 1, 2, 3, 2, 1, 2, 3, 2. And let's have a look at how that looks. There, so that's a slightly different type of animation. The flapping is less pronounced. I think I'll leave it as that one. Okay, so that is frame by frame animation, the basics of how it works. To go back down to this one here, it'd be awesome to see this expanded on a bit, breaking things out into separate classes. Now I'll come back to that now, because this is just one animation, right? There could be multiple different animations running at the same time, and this doesn't scale up to multiple animations. You can't keep putting, like, I can't come in here and put enemy 1 frame 0, enemy 2 frame 0 for every single thing that's going to appear on the screen. This obviously isn't going to work. So what I'm going to do is I'm going to break out this frame-based animation into its own class that is easier to reuse. So you can have multiple of them running at the same time. But before I do that, I'm going to have to break out something else into a class, which is a timer. If you've been paying close attention, you'll notice that we have quite a few time-based updates where we're saying there's 3 seconds left until this thing happens. So animation is 1. We know there's however many seconds left until the frame changes. We've got obstacle countdown here, which is how many seconds until the next obstacle spawns. We've got restart countdown, which is the player's dead, how long until we actually start the game again. So this is a pattern that's turning up quite regularly, and it's always the same. You have an amount of time, you tick it down until it gets below 0 or equal to 0, and then you do something. So here, restart countdown is going down, you check if it's below 0. Obstacle spawning is counting down, check if it's below 0. and same for the player update. So this is obviously, this is a thing. It's not, it shouldn't be custom code every time. We should have some shared way of doing this right. It'll be faster to write in here in the update step, and also more reliable because we won't have bugs like that. The one on player animation frames per second thing. We can fix that in one place and then we don't have to worry about it anymore. So let's make a new class called timer. I'm just going to open up a new file called timer.rb and we'll get started on this class. Okay, so a timer is going to be an object that takes an interval. An interval is how long until this timer fires. And we're going to save that here to F. This will fix the bug. We're converting it to a float as it comes in. So if that was an integer, now it's not. I'll just make sure that that method exists. Float of 5 is 5.0, yes. Okay, so timer has an interval. That is the frame remaining sort of variable. It also has say interval remaining. So I actually got that slightly wrong. Interval remaining is the same as frame remaining. Interval is like one on player animation FPS. So that's the maximum. That's where the interval starts at. And this is where the interval currently is. So this one is pretty much constant, and this one is always changing every frame. Okay, so just to show you how this class is going to work, I'll put it down here. Make a new timer, one on player animation FPS. So you make a new timer that says this timer triggers every 200 milliseconds or whatever this value is here. Then we're going to later on update the timer every frame. So t.update, and we'll put in the delta time, how many seconds have elapsed. And if the update causes the timer to trigger, then we do something. So the next method is update seconds elapsed. And we just do the logic we implemented before. Interval remaining, you take off the seconds elapsed, while the remaining interval is smaller than or equal to 0. We want to do something here. So the timer doesn't include what happens when the timer fires. It just tells somewhere else that the timer has fired. We have to keep in mind that the timer could fire multiple times in a single update. That's why we're using the while loop. The animation might skip ahead 3 frames instead of 1 frame, so we have to be able to fire the timer multiple times when update is called. So we can't just return true here, then down in this code, if the timer was updated, do the thing. That's not going to work. That's not going to do multiple fires. So instead, what we're going to do is yield. So this changes the syntax down here to, you update the timer, and you pass it a block. And the block will be called if the timer fired. If the timer fires 3 times, the block gets called 3 times. And last step is the interval remaining is increased again. Oops. So this is the pattern. You start with a number, you tick it down when it's below 0, you fire the timer, and then you increase it by the interval again. And that will run this code here. So pretty simple stuff. This is a looping timer, so it will keep firing over and over again. We might need a slightly different one in a second, but this will do for the animation. Okay. So in the player state, we got player frame. I'm going to replace player frame remaining with player animation timer, which is a new timer with that. So same interval, but it's a timer object now, it's not just a float. We will need to require the timer up here. And now we have to look for the things we just broke. Player frame remaining, I believe it was called. Okay, so this won't work anymore. Player frame remaining doesn't exist. And what we're going to do is the example code I was typing in before. State.playerAnimationTimer.update. Give it the delta time. And there. So every time the player animation timer fires, we increase the frame by 1. And that should work exactly the same as before. And it does. So that cut down about, what, 5 lines down to 3 lines, and one of those lines is just end. So it was really 4 lines down to 2 lines, which is a 50% reduction, which is good. The next one, obstacle countdown, that is also a timer. So we will convert that to a timer object. I'll change obstacle countdown to obstacle timer. It's a new timer with the spawn interval. Okay, now we've got to find everywhere that obstacle countdown was used and do the same thing. Here's the pattern again. We're going to change that to obstacle timer dot update, give it the delta time, and we can delete out this stuff. And hopefully that works. Yeah, so that's just working same as before. I'm going to take this opportunity to have a look at the chat, because if people are saying that the video isn't working, I've just spent a lot of time talking to myself. Okay, so that's two instances of manual timer code being changed to a timer object. The next one is this restart countdown. So restart countdown is slightly different. It looks the same here. You take it down, check if it's below 0, but it's missing the looping aspect. We don't keep restarting the game every 3 seconds. We just restart it once and stop doing it. So for that, we need a slightly different type of timer. Although this would probably work. No, we'll do the timer properly. Okay, this is a looping timer. We want to be able to make non-looping timers. So, new argument called looping. Defaults to true, so it works the same. If you don't give the second argument, it works exactly the same as what we currently have. Just save that true or false in here. And now we just need to stop. We need to stop if looping is on. So, well, firstly, you don't increase the interval remaining if looping is on. If looping's off, sorry. Actually, I'm going to do this slightly differently. So if this is a looping timer, we just do what we've always done. Whoops. Okay. But if it's not a looping timer, we want to do something slightly different. So we skip the loop entirely, and we do, we still want to yield if interval remaining is below 0. That's not going to work quite right, because every time you call update, the timer is going to fire again. So to stop that, I'm trying to think how to do this the best way. I'm actually thinking of doing inheritance, which I normally wouldn't recommend, but it seems pretty apt in this case. Alright, let's do inheritance. Let's do it. So we're going to make two different types of timers. Looping timer. I'll get rid of all this stuff that I just put in. Let's wrap this all in a module called timer, and so we've got timer looping, and we've got one shot, which will just run once. Okay, and these behave slightly differently, even though they have the exact same interface. Take out that line. And okay, so when we have a one-shot timer, we don't need two instance variables because we're never going to restart. We just need to know how many seconds until this timer is done. And we save that off into interval remaining. I might just call that remaining by itself. An interval sort of implies that it's something that's going to repeat. Or does it? Let's have a look. An intervening time. No, it doesn't necessarily. I'll call it an interval. I'll leave it as interval. Okay, so remaining time, we tick it down still, and yield if remaining is smaller than or equal to 0, and that will repeatedly fire because remaining is going to keep going down, and every time you call update, it's going to fire once it hits 0. So it'll be -1, -2, -3 firing every time. And to stop it from firing every time, we just want it to fire once. We're only going to run if it's never been fired before. So if remaining is greater than or equal to 0. So if it's above 0, we know it hasn't fired yet. Then we go in, decrement, and fire if it goes below 0. Next time it comes in, it's below 0, and this won't run anymore. So it does nothing. It does nothing after it's fired once. And those are our two different types of timers. Now I have to change some stuff because this has changed. This is a timer looping. Timer looping. Run it. Yep. Now it is still working. And now we can finally replace this restart countdown with restart timer. And this is a timer one shot. One short, one shot. Okay. up where that was used. Restart timer, update, using delta time. This is so short, I'm going to put on a single line. There. So update the restart timer and restart the game when it is triggered. We'll just make sure that works. Yeah, all working the same. So that was just a bunch of refactoring. It didn't change how the game worked. It's just under the hood stuff, refactoring into timers. So with the timer working, now we can make the animation class, which I'm going to do now. Animation.rb. I'm just going to call it animation. Probably more accurately, it's a frame animation, but that's fine. We don't have any other types of animation, so it's not going to be ambiguous. Okay, so frame animation takes a list of frames, and it also takes how many frames per second. And we'll write the usage code first. So Casey Muratori, who is doing Handmade Hero at the moment, has some good advice in that when you're going to make something new, you want to write usage code first. You want to see how you want to use the code before you've written it, which is just good advice in general. So let's follow it down here. This is how I want to use an animation class. I want to make one. And I'll give it the frames. So what do we have? We had player 1, player 2, player 3, looping back to player 2, and we had player animation frames per second. I would put this at the front here, just because it's a single argument, whereas the second argument is a list, and the list could get quite long. So that lets you do stuff like you can break this up onto multiple lines, like so. Like that. If this was the if this list was the first argument, then you'd have to put stuff down here, which doesn't look quite right. So try to put arrays on the end of the argument list. So once we have an animation, I want to be able to update it with the delta time at some point. And then when I'm drawing it, I need to know the current frame. I need to know what frame is it on at the moment. And I think that's everything we need from this. We just need to know what the current frame is. We need to be able to update the animation, and we need to pass in the speed and every frame. I think that's pretty good. So let's implement that. I said I would put frames on the end. Okay. And this requires a timer, as we saw earlier. So we're going to make a new timer, a looping timer, and the speed is going to be 1 on frames per second. And I'm going to keep the current index, but we need to keep the frames as well. Okay, so a list of frames, a timer, and a current index, which is kind of what we had back in the other code. Next up is update with seconds elapsed, also known as delta time, and pass that straight through to the timer. And every time the timer fires, we're doing the cycling of the frames again. So the current index equals current index plus 1 modulo the number of frames. Okay, doesn't have to return anything. And the last step, current frame, we can probably make that a little bit shorter. I'm just going to call, that frame, animation.frame, makes sense to me. And all we got to do is look up in the frames whatever the current index is. Alright, so this animation class will be able to run this code down here. Okay, so let's put it in. So instead of player frame, player animation timer, that's sort of what we're replacing. I'm just going to call this player animation, and that is a new animation with player animation FPS and player frames. I'll put this up with the rest of the constants. Where were we? Yeah, okay. So player animation, don't need the animation timer anymore because it's inside the animation object. We do need to require the animation file. And now we need to fix all the code that broke because of this. So player animation timer update, that has turned into state.playerAnimation.update. We can get rid of all of that. Well, I should probably check it first. Yep, that's the logic we just put inside the animation class. And then when we draw player frame, this is now the player animation dot frame. So this will return the symbol, then it goes through. Actually, we don't need player frames anymore because we're already using it up here. When we make the animation, we give it a list of the symbols. This is the constant up here. We give it that list, so we don't need this bit anymore. So all we want is player animation.frame, which is a symbol, and then we look up the symbol in the images hash. And that should theoretically work. Undefined local variable method frames. I've typed something in wrong. And here it is. Okay. All right. So that was a little bit more refactoring into separate classes. I'm trying to think what else we could pull out into something separate. I mean, rectangle could be pulled out into something separate. We don't need anything more from the rectangle at the moment, and it's only like 8 lines of code, so I'll probably just leave it in here. I'm trying to look for other things that have been repeated. That's pretty much it, I think. what we're left with is just code that's really specific to this particular game, not sort of generic code. I mean, here the obstacle scrolling. No, I don't think that can be made generic, really. I think that's pretty much it. I wouldn't take it any further. That's the things that we've just pulled out, like timers. That's pretty generic. You can use that anywhere. Animations. That's generic. You can use that anywhere. We got a vector, I believe. Vectors are absolutely generic. You use them in everything. But other than that, I think that's everything. That's all we want to pull out. So hopefully that sort of is what you're looking for in this comment here. Oh, whoops, wrong one. In this comment here. Break things out into separate classes. These timers, animations, and vectors, you'll either rewrite them every time you make a new game, or you will use an existing one, maybe one that you've made personally before. They're always there, always. I'm kind of surprised that gosu doesn't actually offer timers, because a lot of things do offer timers. Like if we look at SDL, which is a C library, and to see what it sort of offers you. Source code, no. Where are the, oh, whoops. So SDL is a C library that gives you sort of OpenGL access. It does 2D stuff. It's sort of like gosu in a lot of ways. What does it give you? Logging, assertions, rectangle functions, audio, timers, timer support. So they do give you timers. A lot of libraries will give you a timer that basically works like what we've implemented, but it's so easy to do. It's not that important, and I'm actually probably happier that gosu doesn't support it, because there's just less stuff to learn. It makes it nice and simple. It'd be great to see how to add different difficulty levels. Okay. So that is the next thing on the list. Okay, I'm going to start this by we're just going to list out the difficulty levels in data. So we'll have an array of levels, I guess. Difficulties. I spelled that right. Yes. Probably not an array, actually. They should be named. So we'll have easy, medium, and hard. Whoops. And then each one of these has its own list of sort of parameters for the game. So what makes the game easy and what makes it hard? Well, one thing is this gap between the logs. So the bigger the gap, the easier it is to get through. Another thing is the speed at which the logs come out. I think that's probably about it. Maybe you could make the flaps not as powerful, so you have to hammer the keyboard in order to get it to get the bat to jump up at certain things, but that doesn't sound quite right to me. So let's just do the speed that the obstacles come at you and the gap between them. Alright, speed and obstacle gap. So first step is just describing what the difficulties are using just pure data. Let's say that the current settings we have are the medium settings. So up here we have obstacle speed 200 in pixels per second. I'm just going to take that, put it right down here. Pixels per second. And the obstacle gap is 140 pixels. Okay. For the easy setting, let's drop the speed down to, I don't know. Actually, the spawn interval. Spawn interval is another thing that will affect difficulty. When I was saying speed, I'm actually probably thinking of spawn interval. So just to show you the differences, I'm just going to have to put something in here so it doesn't crash when I run it. Okay, so if we pump the gap up a lot, I mean that makes it really easy. The log's actually gone off the bottom there, which we'll have to fix. That's one way to make it easier. Spawn interval. So if I turn that up, you've got just longer in between them. That also makes it a fair bit easier. And then you have the obstacle speed, which I'll double the speed. So now you're flying. Way. That's an interesting game now. You probably don't have time to get out of the way. You can't you can't get out of the way if the obstacles are coming too fast. So we'll have to be kind of careful about that speed parameter because, well, I guess this isn't too bad. It's easy to get caught like that. There's nothing you can do. I'll put that back to normal, and I'll put this back to normal. Let's do all three of those. So we've got speed, gap, and obstacle spawn interval. Okay, that's 1.3 seconds. Okay, I'm just going to fill out easy and hard. I'm going to guess what it should be. So I'll increase the speed to 300. Oh, no, not for easy. I'll make the speed slower for easy. I'll make it 150 instead of 200. I'll increase the gap up to 220 pixels. I should put these in. I like to put the units on the end of things that are a bit ambiguous. Because when I come back to this later and I go 220, what's that? Is that milliseconds? Is that seconds? Is that pixels? Who knows? And I'll bump up the spawn interval to 2 seconds. Okay, and for hard, you want it to go faster, so 300 instead of 200. The gap should be slightly smaller, so 110 instead of 140. And they should spawn more frequently. So instead of every 1.3 seconds, we'll do it every 1 second. Okay. So this is a description of all the difficulty levels that we provide as pure data, which we will now use. So we'll have to get rid of these constants up here that we've duplicated. So obstacle gap. We'll do that first. Obstacle gap. It's used in a couple of places. And that will now be, we'll get the current difficulty and get the obstacle gap out of that. I believe that's what it's called. Yeah, it's still called obstacle gap. Okay, so current difficulty. We need something that will give us that now. So we look in the constant and we have to know difficulty. I don't know which one we are, easy, medium, or hard, and I'm going to put that into the state. Game state. I'm going to put the difficulty in here. And we'll start off at medium. Okay. And back to replacing obstacle gap. That was difficulty obstacle gap. And that is all for obstacle gap. Let's have a look and see if it runs first of all. Yep. Okay, next one to get rid of is obstacle speed. And we want to change that to difficulty. I think it was just called speed. Make sure it's called speed. Yes, it was. Alright, and that is fine. And the last one is the obstacle spawn interval. And this is this presents a bit of a problem. We don't know what the spawn interval is on the timer until we know the difficulty. So we can't just set this constant anymore here. And that's the only place that it's used. So that is a little wrinkle. What I'm going to do is trying to think of the best way to approach this. We're going to be changing the difficulty in the game. So when the difficulty changes, the obstacle timer also has to change. What I'll do is, let's first just delete out this thing. We'll make, the obstacle timer will be a looping timer with no interval. Well, we'll still give a default interval. So medium difficulty, obstacle spawn interval. So we'll give it the proper value for the medium difficulty. That's the default, and we'll deal with changing that once we're switching difficulties. Okay. So now to switch the difficulties, I'll hang it off the keyboard again. KB1. So I'll just do 1, 2, 3. 1 is easy, 2 is medium, 3 is hard. We'll make something called set difficulty easy. 1 is easy, 2 is medium, 3 is hard. Now I have to make set difficulty. Name. We'll use name. Easy, medium, hard are sort of the names of the difficulties. Okay. So, first thing we do is set state.difficulty equals name, which is what we want. The second thing we have to do is we have to update that timer. So the obstacle timer interval equals the obstacle spawn interval. We have no way to do this at the moment. This dot interval equals doesn't exist, but we're about to add it. But that should be enough to do it. So as soon as you set the difficulty, the other parameters change, like the speed that it's scrolling and the gap, they change automatically. But this obstacle timer needs a little bit of extra help to change. So let's do this here in the timer. Interval equals new interval. And that should be enough. What this is going to do is, when we change the interval, it's not going to change the current countdown, but when it loops, that's when the new interval is going to kick in. We could do something more fancy, where if you change the interval, it also changes interval remaining. So if you were like 30% of the way to the next loop or the next timer trigger, and you change the interval, it could change that to 30% of the new interval. Maybe that's slightly more accurate. You'll see the results more quickly on the screen. You don't have to wait for the timer to fire before the new interval kicks in, but not really necessary. You won't be able to notice it anyway. So I think that's fine. After the timer fires, that's when the new interval kicks in. And hopefully that is enough. Let's run it and have a look. Okay, so this is medium difficulty. It's already too hard. Okay, medium. Oh my god, I can't play my own game. Okay, I'm going down to easy. Ooh, that obstacle disappeared off the bottom when I changed to easy. Oh, it's because the gap changed. That's interesting, actually. So this is medium. Every time the game restarts, it goes back to medium. I think medium needs to be changed, it's too hard. But if you can see, when I change to easy here, the gap gets bigger and everything slows down. There are a couple of bugs. The log's going off the bottom of the screen sometimes. It's because it doesn't. It's not accounting for the variable gap. The gap was constant before, so we could just use a constant for saying where the gap appears, the highest and the lowest the gap can appear, but that's not going to work anymore. So easy is nice and simple. We go back up to medium. Whoa, the log hits us in the face. The logs probably shouldn't change as soon as you change the difficulty. Let's have a look at hard before I go. So it's speeding up. Woo! That is tight. That is hard. So there's a couple of buggy things that have happened now that we've put in difficulty switching. First, I'll fix the logs going off the bottom of the screen. Actually, no, I won't. First, I will fix the logs jumping when you change difficulties. And for that, all we've got to do is just say, in the obstacle has to know what its gap is. So when you create the obstacle, it gets given a gap from the current difficulty, and that never changes for the life of the obstacle. Default gap is, let's just give it the medium difficulty gap. Okay. Now we've got to see where the obstacles are created. New obstacle. We'll set the gap in here. Not fap, gap. The difficulty obstacle gap. Okay. Now let's just check that that works. I'm going to change from medium to easy after I see the first log. Nope, still changing. Oh, right, because this value is right, but it's not actually drawing based on that value yet. So we need to go to the draw. Drawing the obstacles. Yeah, difficulty obstacle gap. We need to change that to the gap that's stored in the obstacle itself. Obstacle.gap. And I think let's have a look and see where else this is used. Difficulty obstacle gap. This one also needs to be changed. Yeah. Okay, so the only place that the difficulties obstacle gap is actually used is for a default up here, which immediately gets overwritten anyway. And when an object is created, this is really the only place that we use it. So now I'm going to change from medium to easy, and there you go. First log was a smaller gap, and when we changed to easy, it didn't jump anymore. But they're still going off the bottom of the screen, which is the next thing that I should have a look at. And we're already in the right place. We've got position of the log is random between 50 and 320. So there is an issue with this because 320 is wrong. It has to depend on the obstacle gap. So we'll work something out based on that. We'll first have to save the gap off. We have to know what the gap is before we work out the position. And now let's play with these values. I believe 50 doesn't have to change. 50 is the topmost. And the topmost never changes because gaps go downwards. So even if we make the gap bigger, that's going to be fine. Yeah. So it's the bottommost value that we're concerned about. Okay. I'm going to make the gap 0 just for testing purposes, and that's the height of the screen there. Height. If I set that to the height of the screen, that should be right at the bottom. Yeah, okay. So we want height. If we take 50 off it, so if the if the highest that the gap can be at the top is 50 pixels from the top, probably want it the same thing on the bottom, 50 pixels from the bottom. That should probably be a constant. So let's put obstacle padding equals 50. And I'll put this down because it's not as important. Okay. So just to go back, get rid of that. Obstacle padding is the highest that it will ever be. Yep. And the lowest that it will ever be. Let's put this in the lower bound. The lower bound is the height of the screen minus obstacle padding. Let's have a look at that. Yeah, so that's the bottom log shouldn't ever be lower than that. Now once we introduce the gap, so we'll put in the proper gap here. And I'll take that off the end. Okay, now the bottom log does go off the bottom of the screen, so we have to account for the gap of the obstacle. So height minus obstacle padding minus gap. And there, that's the lowest that it will ever go. Okay. Now we've got the lower bound. We can make this random again. So instead of using the lowest, we know that it ranges from obstacle padding is the highest to the lower bound. And now switch modes to easy. And it's not going off the bottom of the screen anymore. I mean, it's random, so theoretically there could still be a bug, but it doesn't appear to be. Should have shown up by now if there was. Okay, back up to medium difficulty. Cool. Yeah, I'm just going to tinker with these values a bit because I think medium is slightly too hard. I'm going to put up the gap between the obstacles. Okay, so this is easy. Going up to medium. That is definitely a bit harder. Probably leave that there. Let's have a look at hard. Ooh. Hard is actually easier than medium. You don't have to flap as much. So let's make hard a little bit harder. Make it faster. Yeah, that's a bit better. Ooh, ooh. Yeah. Okay, I like those. So that's the 3 different difficulties. Just to finish this off, I'd probably say when we restart, we probably want to keep the same difficulty. So we'll go we'll remember what difficulty it was. All difficulty equals, we'll remember it, we change to the new one, and then we set the difficulty to the old difficulty. Okay, so medium just died going at hard difficulty, and we're still in hard difficulty. Go down to easy, medium, we'll die in medium. and still in medium. Okay. So if you want to play on hard repeatedly, you don't have to keep changing it. And I think we should probably say what mode we're in, because I mean you can't even tell if you're on easy, medium, or hard. So let's just draw that. We'll draw it down in the corner of the screen so that you can see it. Draw. This is where we draw the score. I'm just going to copy that and difficulty. I'm going to draw the difficulty down, let's say the bottom right. So we want the width of the screen, give it a little bit of padding, 10 pixels from the right. The Y should be the height of the screen with a little bit of padding again. So this is the bottom right corner. And this is where to draw the text relative to the bottom right corner. And 1, 1 means put the bottom right of the text in the bottom right corner. Hopefully that will work. Medium, easy, medium, hard. Text is a little bit big actually, but I mean, that'll probably do. I mean, you can make a new font, different colors and different sizes, whatever, to draw this text down the bottom right. But I'm just going to use the same one that draws the score because I'm lazy. Yeah, cool. Confetti every 10 points. That's actually a quite a good suggestion, because that's sort of like a particle generator, which we haven't looked at. Let's do that. Let's make a particle generator. It's for fun. Everyone likes particle generators. So not sure exactly where to start with it. We'll need a particle first of all, so like some sort of picture. Desktop images. I'm just going to call it particle.png. Should probably, it's too big to be a particle, so let's just make that a little bit smaller. And the best image editing software that exists, Preview. Alright. So, we've got to load that image in, first of all. Particle is particle. Okay, now we need a list of particles. Let's make a new thing for it here. So particles have position, they have a rotation, which we'll say is just nothing to begin with. Position, rotation, scale. I'm going to make that a single number. So we'll have different size particles, they'll be spinning, they'll be obviously at different positions. So if they're going to spray out at different positions, they also need their own velocity, which is also a vector. We'll start off with no velocity. So if all the particles start at the same position, like behind the score, then they will all be given a random velocity, sort of up in the air, which will make them spray out. Also be given a random rotation, so they'll spin. Random scale, so some will be little, some will be big. And probably a color tint. I think a color tint would look good. Now we just got to see if gosu will let us do a color tint. Just going to dig through the documentation. Yes, they do. color. Cool. All right, let's give them a tint as well. Whoops, don't want to quit. Gosu color white. So white means no tint. What happens when you tint a color? So you have a red, green, blue value, and then you have a tint, which is also a color, a red, green, blue, and you multiply them together. So you multiply red by red, green by green, blue by blue, and that gives you the tinted color. With white, white is full red, full green, full blue, so 1, 1, 1. When you multiply by 1, nothing happens. So a white tint means that it doesn't change the color at all. It's only when you change this to something slightly different you'll actually see a difference. So that's all we need for a particle. We'll put it here next to obstacles. Particles is an array of particle. And now we need to find out where your score goes up. Where does score go up? Score plus equals 1. We'll chuck in here particle burst. And we'll implement particle burst down here. Okay. So how many particles? Let's say 10. So 10 times we want to make a new particle. So state particles, we're going to add into it a new particle. And now we've got to do all that stuff that we just put up the top. So what's going to be random? All of this is going to be random, except for position. Okay. So the position is always going to be behind the score. And where is the score drawn? I'm just going to steal these values here. So the score is drawn at width divided by 2 for the x and 60 for the y. I'm just going to steal that, put it right here. Velocity has to be sort of random. So x velocity. Negative will mean the particle will go to the left. Positive means the particle will go to the right. So let's make this random. We'll say 60 pixels per second to the left, 60 pixels per second on the right. So it'll be something random between those two. And for the y, negative means up and positive means down. Probably don't want them to start out going down. We'll put gravity on them afterwards, but when they first burst out, it probably should be upwards. So between 1 pixel per second and 100. So that says upwards, and it can be left or right. Rotation, give it something random between 0 and 360. Scale. So for scale, 1 means exactly as big as it is, so 30 pixels. We'll go from smaller than that up to 1. So 0.2 up to 1.0. Hopefully that works. A lot of dots in there. So that means 1/5 the size up to full size. The tint is a little bit interesting because we have to generate a random color. So if I look at the gosu docs for color, red, green, blue, how do you make a color? Initialize ARGB, so alpha, red, green, blue. And they go from 0 to 255. So that's easy enough. Gosu color dot new. I can type. And we want alpha will always start at 1. No, alpha channel goes up to 255. Okay, 255 means fully visible. Then red, green, and blue will all be random. Okay, we could do 0 to 255. That will give you any old color. I guess we'll do that. Can always change it later. And that's it. So lots of randomization. They're actually not going to rotate. They'll come out rotated, but they won't spin because we don't have any rotational velocity, which I will put in now. Particle rotational velocity, sort of like we did when the player dies. When the player dies, it spins. Okay. Rotational velocity. This is in angles per second, degrees per second. So what do we want? Say negative 360 to positive 360. So spin to the left or spin to the right. You can always change that later. So that makes 10 particles, all randomized, all with different tints and whatever. All on top of each other at the same point. So we're going to have to update them. We'll update them up here with the player animation. So even if the game hasn't started, so maybe when you get a point and you immediately die, there'll be particles in the background when you're dead. You still want those particles to animate, maybe even if the game hasn't started yet, if there's any left over from the last game. So we'll update them before the return unless started. And that will be state particles, each do, call it part, and here we go. So the particle position increases, I didn't type that right, increases by its velocity. And we have to integrate that with the delta time. To apply gravity, we're going to do, this is the same as the player pretty much. Player has a velocity and a position which is affected by gravity, and particles also have a position and velocity, and they're also affected by gravity. So these two lines here, we're basically copying that. So the particle velocity plus equals delta time times gravity. What is next? That's enough so that we can probably look at it. So I'll just leave that for the moment. We haven't done rotation or anything. And then we've got to draw them because we can't see them on the screen at the moment. I will draw them. Let's draw them between the background and the foreground, because I think that might look cool. So state particles, each do part, get every particle, draw the particle image. We want draw rot for rotation. XY. Position.x, position.y. I think that's Z. I should have a look at that. XY, Z angle, yes. Okay, so Z is 0. We're not using the Z index at all, we're just drawing everything in order over the top of each other. Next up is rotation. I think that's it. XYZ rotation. Is that right? XYZ rotation. Yep. All the other ones are optional, which we will come back to shortly. And hopefully that will just run. No. Initialize constant gosu color white. I spelt that wrong. This should be capitals. Okay. Alright, they're there. They are there, but they're not shooting upwards. They're shooting downwards because I got the y-axis wrong. I think that's kind of cool, falling behind the trees. So let's just change that y-axis at the moment. So the mistake I made is that these are positive numbers on the y-axis, and positive means down in gosu, so we actually want them to be negative numbers. Let's have a look. Undefined method plus for nil class. I probably should have looked at that error a bit better. And that's interesting. I don't see what could have changed because it was working fine, like so. Let's have a look at what random does. So 1 to 100, we get that. -1 to -100 is nil. That's definitely our problem. Oh, okay, so the range was wrong. You have to put the smaller number at the front, larger number at the end. So let's do that. -100 up to -1. Okay. All right. They're not spraying up very good. They need to be bigger, so a bit higher and probably a bit further out to the left and the right. So a little bit higher and more out to left and right. That looks a bit better. Okay. That's really distracting, actually. That's good. That's what we're here for. We're here to make just stuff that looks stupid. For fun. Edutainment. Okay. So, they've got a bit of randomness to them, but they're not drawing everything that we made. They're all the same size, they're not spinning, that sort of stuff. So, where's the draw? Okay. So we've got a little bit more to do here. rotation. So we are drawing with the correct rotation, but I don't think we're updating the rotation at all. Each particle, no, only position and velocity. So rotation plus equals delta time particle rotational velocity. Let's have a look. Now they should spin. Yeah, there we go. So they all spin slightly differently. Cool. We said we're going to tint them different colors. That's not working yet, so we just have to draw them with that random tint we made. Where's the tint? Center X, center Y, factor X, factor Y, color. Okay, so center X, center Y, factor X, factor Y, and the color. Hopefully that will work. Yeah, they certainly are tinted different colors. Not very nice colors, they're probably too dark. We might have to brighten them up a little bit. Let's do that now. Tint. So 0, 0, 0, 0 is black. We probably want to stay away from black. So let's go from 200 to 255. That'll only make bright colors. So they are slightly tinted, but you can't really see the difference. It's probably a little bit too bright, too close to white. So let's turn this down to 150. Oops. Yeah, I think that's a bit better. You can see that they're slightly different colors. That's tinting. We have a random scale, so there'll be different sizes. That needs to go in here. This is this parameter here. R.scale.x, scale.y. Undefined method x for float. Oh, right. Scale is not a vector, it is just a single number. There, I got some little ones, got some big ones. The little ones are probably a little bit too small. I don't know. No, they're alright. Actually, I think they're maybe a little bit too small. Make the smallest ones a bit bigger. And what else is on here? So gravity, they spin, scale's different, tinted. That's about it. If you remember back to the obstacles, I said this line here. I said every time we make an obstacle, they were never being removed. Even though they'd gone off the screen, you'd never see them again. They were still there. And that's not very good for like performance. Now that we have multiple particles, it's even worse. Instead of one obstacle every like 1.3 seconds, you get 10 particles every 1.3 seconds, so it's 10 times worse. We're going to have to remove the ones that have disappeared off the screen just for performance reasons. And that's pretty simple. We just do the same thing. State.particles, reject. We're going to remove all the particles that have gone off the bottom. So they're going down with gravity. Once they hit the bottom of the screen, we'll just remove them. So if the position.y is greater than or equal to the height of the screen, they're going to be removed. I should probably test this. I'm just going to print out the size, how many particles there are in that array. So it's sitting at 0, 10. Okay, so it's hovering between 10 and 20, which is correct. It's not always increasing. Okay, that'll give us a bit better performance, especially the further along you go. And yeah, I think that's about it for particles. Cool beans. So there you go. Exploding particles every time your score goes up. Might just add some more. See what happens. The more the merrier. I think probably one of the last things we'll do, just because it's easy and it makes quite a big difference, is sound. So just adding terrible sound really makes your game better, just a lot better. It doesn't even have to be good. Okay, I'm back and I have some music available that we can now drop in. So, really simple. Music equals gosu. Is it sound or music? Let's have a look. Got gosu sample. See also gosu song. Song is what we want. Initialize window file name. Okay, so a song is long audio, and you can only have one of them playing at a time. New thing. I put in audio/music.mp3, and I'm just going to start playing it immediately. True means loop, I believe. Play looping equals true. Yep. Let's have a listen. So it's like some Spanish guitar thing. I don't know if you can hear it very well on the stream, but oops. Pretty good. Pretty good. Just want that to loop forever in the background. Alright. Well, that was music. 2 lines of code. Easy. In fact, make it 1 line of code. We don't need to save it. We never touch it again, so we'll just make the object, start it playing, and forget about it. Although it may be garbage collected. Double check. Yep, got garbage collected. So what happened here is, because we're not saving the song to any variable anywhere, Ruby garbage collector eventually comes along and says, hey, no one's using this song, let's delete it. And it gets deleted while it's being played, which isn't what we want. So we actually do have to save this off somewhere, even though we're never using it. The other type of sound that we want, BFXR. BFXR. If you haven't heard of it, bfxr.net is just like a sound generator. It'll make little glitchy, sort of retro-y sound stuff. Just randomized. So those jumps, they sound terrible. That sounds horrible. That is just truly grating on my ears. But it'll do. It will do. Save to disk. Export as wave, export. Call it FreeBat, no, screencast, audio, jump, dot wave. And we want a noise that plays when you get a point. So that's really bad. That is terrible. But I'm going to use it. I'm going to call this score.wave. And let's load them in. So we've got a hash of images here. We'll do the same thing for the sounds. We have, what do I call it? I call it flap or jump. Got jump. Should probably call it flap, you know. It's wings, it's not a jump. So we want gosu sound sample, I believe. Let's have a look at sample. Window file name. Yes. Audio / jump.wave. And score, same thing. Score.wave. So these are samples, gosu samples, not gosu songs. Gosu song you can only play one at a time, and they're generally for larger things. Gosu sample, you can play as many as you want, but they have to be short. It's because their samples are completely loaded into memory, I believe, and songs are not, because songs can be quite large. So samples have to be short, but you can have multiple. Songs can be any size, but you can only have one. Now it is super simple to play these. Here's where a flap happens. So we just play the flap. May need to adjust the volume on this because it sounds so terrible. Volume, speed, and looping. We absolutely do not want it to loop. We'll try full volume, see how long we can stand that. I spelt it wrong. Sounds. Why is the music stopping? Oh, garbage collector problem again. This dot play, it doesn't return the song. So it returns like true or false or nil or something else. So we actually, it's the same problem. The song's getting garbage collected. What we want is save the song and then play it next. That is horrible. I'm going to have to turn that down quite a bit. So 0.5, 50% volume. Almost bearable. 30% volume. Yeah, that's better. You'll notice that the sound sounds really repetitive if I jump a lot. I also noticed that it also plays if you're dead. And we don't want it to play if you're dead because you can't flap if you're dead. We've got if state alive over here. What we want to do is just wrap that in here. So if you're alive, then flap play the sound. If not, okay, so as I was saying before, it sounds really repetitive and it just doesn't sound very good to have the exact same sound repeated. It sounds a bit like Mario or whatever, but we can do better than that. Here you see we have volume, speed, and looping. Volume we've already set. Speed is at 1. If you put a little bit of randomness into the speed, so 0 is, I don't even know what speeds are allowed. There are limits. The playback speed. We'll just put a little bit of randomness into it. A little bit. So 0.9 to 1.1. Now let's have a listen. So every time it jumps now, I'm going to stop the music playing so you can hear it. But every time it jumps, it actually makes a very slightly different sound. The pitch is different. Sounds like Banjo-Kazooie, someone talking. If you've ever played that game. If you haven't played that game, look up Banjo-Kazooie Witch talking. It sounds almost as terrible as this jumping sound here. Yeah, so I mean, it just sounds a little bit better. It's less repetitive. So putting that little bit of randomness into the speed. So we'll use that trick again. The next thing we want is the score. So here's where the score goes up. Same thing again. Sounds, score, play. We'll want to turn the volume down 50%, and we'll put in a little bit of randomness as well. Same thing, 0.9 to 1.1. So that's 10% slower to 10% faster. This is truly a terrible combination of sounds. Okay, for this one, so we could make this random, like we did for the last sound. But what's nicer in games where you're advancing, so your score's going up, instead of it being random, it can just increase a little bit every time. So every time you go through a thing, you can go do it, 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 do it. So it feels like you're advancing. Is the effect you get there. So let's do that. We will use the. We'll make it go faster depending on what your score is. So I'll take out that randomness. Let's move it down after we've increased the score, and we'll play from 0.8 up to no, it's not a range, sorry. 0.8 plus your score, but we have to scale that down a bit. You don't want the speed to double when you get one thing. That's going to be too high. But maybe 0.05, just a little bit. Let's see how that sounds. I'm going to turn off the rest of the sound so that you can hear that. What are we looking for? Play. Turn off the flap, and we'll turn off the music. Okay. So as you can hear, it's getting higher and higher pitch. don't know what the limit is. There's probably a point where you can't go any higher, like triple speed or something might be the maximum. Don't know if I can be bothered playing long enough to get to the maximum. No, I'm dead. I can't be bothered playing long enough to find the maximum, so I'm just going to leave that in there. I think what I am going to do is turn down these even lower, because I don't want to drive people insane. When people play your games, they probably shouldn't need to go on psychoactive drugs afterwards. It's usually a mark of a good game. So we're going to turn these down. Even lower, I think. That score sounds especially bad. Tiny bit higher. I think that's pretty good. Yeah, that'll do. Modsky's saying, is this hardcore or casual? Probably neither. It's probably just more educational purposes. If you wanted to make like a proper game that you're going to distribute to other people, you've got to consider a lot more than what I have for this. So you could probably distribute a Ruby game like this to your friends, but you have to go tell them, oh, go install Ruby, and then I'll give you these files, and then you go in and you do this in the commands, and you type in Ruby game, and it's not very distributable. You probably want, if you want to make a real game, you probably want to invest in learning some web stuff like Phaser. Phaser is a really good web framework if you can use JavaScript without hating yourself. Yeah, you could do it as a native app for phones or something like that. But yeah, this is really just educational. This is really easy to make something for yourself. Minimal code. That's why it's in Ruby. Good. It's good if you're like a beginner, I think. I'm actually considering making a series or a course that teaches people how to learn programming that don't have experience, probably using Gosu. Start off at text adventures, because that's definitely a lot easier, but graduating into Gosu as it goes along, just because it's doable. It's doable for someone who doesn't know programming very well. It's quick to get set up, pretty quick to learn as well. Oh, let's just play the game one more time. Just to see it in all its glory. Difficulty levels, score, particles, lots of sound, horrible sound. Yeah, but I mean, it's a playable game. It's a completely playable game. It didn't take very long. Experienced developer could easily do this in under a day. Someone just learning could do it over the course of a few days, probably. So yeah, that's probably it for Flappy Bird. Unless anyone really wants to see anything else, I might do a third one. But I think that's pretty much wrapped up. So there you go. If you want to make a game in Ruby, now you've got 100% of it coded live that you can use as a reference, and all the code is available on GitHub, or at least it will be once I do that right now. So this is where you go if you would like to check out the code. Yeah, so thanks for tuning in, and hopefully I will see you sometime in the future with some other sort of project.